morning, students. So now we are going to see one important 2-mark question. What is free body diagram? So the free body diagram is nothing but it is a simple tool to analyze the motion of an object using the Newton's law. So using the Newton's law, we are going to find what are the forces acting on an object using the free body diagram. Here there are 3 important steps to draw the free body diagram. Now we see one by one. The first one, identify the force acting on the object. That means we have to find which direction the force is acting. So what are the forces acting on an object that we have to find. Then second one, represents the object as a point. So the mass of an object is considered as a dot point. Third rule, draw the vector representation the following forces acting on the object. So we have to represent the vector notation for the force acting on the object. So these 3 points is very important for draw the free body diagram of an object. An important point, when you are draw the free body diagram of an object, the force extended by the object should not be included in the free body diagram. That is, the expanding of the force be never included in the free body diagram. Students, now we are going to see the particle moving in an inclined plane, page number 122. Now consider an object is moving in an inclined plane. Okay. So we are going to calculate what about the acceleration due to gravity, that is what about the speed of an object reaches the ground in a certain height. Now when an object of mass m sliding on a frictionless surface or the inclined plane angle theta, then the forces acting on it will be calculating the acceleration of the object, then what are the speed to reaches the object. So at what speed it reaches the ground. So these 2 things we have to find. So what is the 2 things? One is acceleration of the body, then another one is the speed to reach the ground. Before start the free body diagram for this object moving in an inclined plane, so we have to know what are the forces acting on an object. So that there will be 2 forces acting on an object. So one is downward gravitational force is equal to mg, and another one is normal force which is perpendicular to the inclined surface. So these 2 forces acting on the object moving in an inclined plane. Student, see this diagram. An object of mass m is moving in an inclined plane. The h represents the height of the inclined plane, and L represents the length of the object reaches the ground, and S represents the displacement of an object, and theta represents the angle of the inclined, and A represents the acceleration of an object to reaches the ground. So these are the diagram descriptions you have to write. Then we going to draw the free body diagram of this diagram. Also, what are the components represented in the diagram also we are going to see right now. Students, here the mass is considered as a dot point, and what are the forces acting on the object is, one is normal force which is perpendicular, and another one is downward gravitational force mg, which is represented in the free body diagram. Then another diagram represents the component diagram, that is when the object is parallel or perpendicular to the force, that is represented here mg cos theta and mg sin theta. So first thing we are going to see the gravitational force mg. So the gravitational force is represented as mg, and this gravitational force is resolving into 2 components. One is parallel component and another one is perpendicular component. The parallel component is represented by mg sin theta, and the perpendicular component is represented as mg cos theta. So very important thing, student. When you are write the component, you have to know which is mg sin theta and which is mg cos theta. So the mg cos theta is always perpendicular to the object, and the mg sin theta is always parallel to the object. Students, already we know we are going to find two things. One is acceleration of the object and another one is speed of the object reaches the ground. So first I am going to calculate the acceleration of an object. Okay, so to calculate the acceleration, it covers the two axes. One is x-axis and another one is y-axis. So first I am going to calculate the y component. Now in the y-axis, the object covers only in the x direction, not in y direction. So the acceleration will be equal to 0. So for calculating the acceleration equal to 0 in y component, so substitute this value in Newton's second law. We know F is equal to ma. Here a equal to 0. Therefore we get F equal to 0. This is equation number 1. Then using the component diagram, we find the another force. F is equal to minus mg cos theta into j cap plus n j cap. That is, the mg cos theta and the normal force are always perpendicular to the object, that is in y direction. So equating these two equation 1 and 2, so we get minus mg cos theta into j cap plus n j cap equal to 0. Since we know j cap into j cap equal to 1, so we get minus mg cos theta plus n equal to 0. Now the minus mg cos theta will move in the right side and become plus. Therefore n is equal to mg cos theta. This is equation number 3. So we find the y component. Next we are going to see the x component for the acceleration. Students, if you see the diagram clearly, the object covers only in the x direction. So in the x calculation, x-axis, the acceleration will be takes place. Okay, so the component of the x-axis is represented as I cap. So from Newton's second law, we know F equal to ma. So calculating in x-axis, we are using the I component. Therefore F equal to ma I cap. This is equation number 4. Then calculating the component diagram, which is parallel to the object. Therefore F is equal to mg sin theta into I cap. This is equation number 5. Now combine this equation 4 and 5, both are equal to force, and we get mg sin theta into I cap equal to ma I cap. Here then I cap will be removed, so we get mg sin theta equal to ma. Now cancel the both side, common term m in the opposite side, we get g sin theta equal to a. Therefore the acceleration of an object moving in an inclined plane, a is equal to g sin theta. So this value, equation 6, is very important. The equation 6 represents the acceleration of an object moving from the inclined plane. So next we are going to find the what is the speed of an object reaches the bottom. For calculating the speed, so we are going to substitute the theta equal to 90 degree, which means the sin 90 value equal to 1. So substitute in the equation 6 we get, so g into 1 equal to a, or otherwise a equal to g, that is acceleration is equal to acceleration due to gravity. Calculating the speed, we are going to use the third equation of motion, which we studied in the earlier, that is v square equal to u square plus 2a s. Initially an object is at rest position, therefore the initial velocity is considered as a 0, that is u is considered as a 0, and substitute in this third equation of motion, we get v square equal to 2a s. Since we know a is equal to g sin theta, and substitute here, we get v square equal to 2gs sin theta. Since we need only the speed, the square will move in the opposite side and becomes v is equal to square root of 2gs sin theta. Since we know the distance of the object covering in an inclined plane, and what about the angle, and we know the g value, and substitute all the values, and finally we get the what is the speed of an object reaches the bottom. Okay, so this is a general concept in the studying an object moving in an inclined plane. So here we found only two things. One is acceleration of an object and another one is speed of an object reaches the ground. Now we solve some problems. Example 3.1. A book of mass m is at rest on the table. So we have to find the three things. First one, what are the forces acting on the book? Second one, what are the forces externed by the book? And third one, draw the free body diagram for the book. Students, a book is placed on the table in the rest position. So what are the forces acting on the book? What is the force extended by the book? And draw the free body diagram of the book. So these three things we have to find when the book is at rest. So very important problem. See, a book is on the top of the table, or otherwise you can say the book is at rest. Even though an object is at rest, there will be two forces acting on it. One is downward gravitational force and another one is normal force. So it will be in the equilibrium position, then only it will be at rest. So first we solve the solution. So already we know there are two forces acting on an object. One is gravitational force mg acting downward on the book, and second one normal contact force, that is N, extended by the surface of the table on the book. So it is acting upward. In the figure you can see this normal force acting upward. Also you see the free body diagram. The book is considered as a dot and the normal force is upward and the downward gravitational force is mg. Student, next problem, example 3.6. The position vector of a particle is given by r vector equal to 3t I cap plus 5t square j cap plus 7k cap. Find the direction in which the particle experiences the net force. Now we solve this problem, students. First we are going to find the velocity of the particle. Since we know the formula of velocity, v vector is equal to rate of change of displacement by time taken, that is v vector equal to dr vector by dt, and substitute the r value. So we get d by dt of 3t I cap plus 5t square j cap plus 7k cap. Now the differentiation part will be separated to the x component, y component and z component. Then we get v vector equal to d by dt 3t into I cap plus d by dt 5t square into j cap plus d by dt 7k cap. Students, here we are going to differentiate with respect to t. So wherever the t terms only we are going to differentiate, then other term will be neglected. Therefore, the differentiation of 3t is converted into 3 and 5t square is converted into 10. That is 2 into 5 becomes 10t. The square will be converted into only t. And 7 will be neglected because there is no t term, we removed. So therefore the position vector dr divided by dt is equal to 3 I cap plus 10t k cap. So only the t terms will be differentiated. So next we are going to find the acceleration of this particle. So acceleration is equal to dv divided by dt. Here also the v value is substituted, or otherwise we can say the substituting the acceleration in the second derivative we get d square r divided by dt square. Again we are substituting the r value here, that is 3 I cap plus 10t j cap. We get only the 10 j cap. Only in 10 we having the t value and 3 having no t value, so we just remove that one. Therefore the acceleration a is equal to 10 j cap. Now coming to the conclusion. So from this answer, so the particle having the acceleration only in y component in the absence of x direction and y direction. So therefore no net force acting on the x or z direction. Only in the y direction only the object will be moving. This is the conclusion. Okay students, today's session.